In this part, we're going to focus on solving natural log equation. But before that, let's talk about one special case that will help you solve natural log equation. So let's take a look at the example we have here. I have natural log of x equals to 3. So in order to solve this equation where we're going to get x by itself, at the moment x is within, I repeat, within the natural log function. So in order to basically get rid of that natural log, I'm going to write natural log as an exponent of e, meaning that I'm going to raise this. I'm going to raise e to the power of natural log of x, same thing as over here, e to the power of 3. So basically, when you have natural log of x equals to 3, you rewrite it as e to the natural log of x equal to e to the power of 3. So whenever you have e being raised by natural log, then what's inside the natural log, which is x, I'm just going to bring it down, write it as a regular size, and then x will equal to e to the third power. So you would just type in the e function, the e constant, and then raise it to the third power, and then you will get your decimal answer. But here, at this point, I would just keep this if you're working without the calculator. So to review, when you're working with natural log equation, simply just raise what you have as the exponent for e on both sides, and then what's inside the natural log, you just bring it down and write it as a regular size, in this case a regular size x, and it's equal to e to the third power. And if you need to find a decimal, you type in the e constant and then raise it to the third power. In this example, we have natural log of x minus 6 and then minus natural log of 9 equals 3. So in order to solve this natural log equation, we need to condense into a single natural log. So basically, using the properties of natural log, so if you were to rewrite it into a single natural log, here we have a minus, so that means I'm going to be using quotient property. So the quotient property meaning that it's going to be a fraction inside natural log. So for my numerator, it will be what is written first, so x minus 6. And then what is written second, 9, will be in the denominator. And this is inside of natural log, x minus 6 over 9. And then the whole thing is equal to 3. So from there, in order to get rid of the natural log, I'm going to use the e constant, raise it to the power of natural log of x minus 6 over 9 equal e to the power of 3. So when I have e being raised to the power of natural log, then I'm just going to bring down the inside, write it as a regular size x minus 6 over 9 equal to e to the third power. Now from there, since I have a fraction, I'm basically going to multiply both sides by 9. So these two 9 will divide into 1. I'm left with x minus 6 equal e to the third power times 9 is simply 9 e to the third power. And then I'm going to add 6 to both sides. So x equal 9 e to the third power plus 6. So that would be my answer for x if I were to do this without a calculator. So let me box that up. So again, x equals 9 e to the third power plus 6. But if you were working with calculators and you were trying to find the decimal value, so here's our scientific calculator. So first I'm going to input the e constant, e. Well, I don't have to because right now it's 9e to the third power plus 6. So since I have 9e to the third power, what I'm going to do is I'm going to put this in parentheses. I'm going to put 9, then input the e constant, raise it to the power of 3, close parenthesis, and then I'm going to add 6, hit enter. I get 186.7698, so let me write that down. So x will be approximately 186.7698. So that would be my decimal answer if you were asked to find the decimal value of 9e to the third power plus 6. So that would be our answer, the decimal answer. But if you were working without the calculator, then you would stop at 9e to the third power plus 6. That would be your final answer. In this example, I have natural log of x minus 7 and then minus natural log of 10. The whole thing is equal to 5. So just like the last example, before I can start solving it, I need to condense these two natural log into one. So I'm going to be using the quotient property because it's subtraction. So the quotient property states that what is written first will be in my numerator, x minus 7, over what's written second is the denominator. So we have x minus 7 over 10 inside the natural log, and the whole thing is equal to 5. Now once you get into a single natural log, then I'm basically going to raise or use the e constant, raise it to the power of natural log of x minus 7 over 10, and then on the right side raise the e constant to the power of 5. Now since I have e to the power of natural log, I'm going to bring down the inside, write it as a regular size x minus 7 over 10 equal to e to the 5th power. From there, I'm going to multiply both sides by 10 since I have a fraction on the left side. So here the 10 would be divided by 10 and become 1. I'm left with x minus 7 equal e to the 5th power times 10 will be 10 e to the 5th power. From there, I'm going to add 7 to both sides. So I'm going to have x equal 10 e to the 5th power plus 7. If you were just solving for x without a calculator, this would be my final answer. Now if you were working with a calculator and you're just trying to find a decimal value, alright, so let's type in what we have. So I want to group the 10 e to the 5th power together. So 10, then have my constant e function, raise it to the power of 5, close parenthesis, and then plus 7, hit enter. I get 1491.1315. So to the 4th decimal, I'm going to raise it up to 1316. So let's write that out. So x, so the decimal value is x is approximately 1491.1316. So that would be the decimal value if you were solving with a calculator. But again, if you were solving without, then this would be my final answer. X equals 10e to the 5th power plus 7.